As a child, I yearned for the mines, but there was always something getting in the way.
I studied hard, taking
God,
classes
get
like
out of here!
And science. And history.
They did everything they could
And
to try to stop
English.
me.
But the call to the mines was too strong. And one day, I discovered these strange ruins.
Riemann sum!
Riemann sum is used to approximate the area under a curve. What we're going to start with here is we're going to divide the table into 4 subintervals. And we're going to bring down our constant of 3, the change in x, and put it right here. Then we're going to add up all the y values starting from the left and excluding the right because it is a left Riemann sum. When we add those all together, we get 3 times 26, which is equal to 78.
Go.
Henry, where are you? Welcome to Calcraft. You can do whatever you want. Zero limits.
So we're given a limit as x approaches 0, sine x over x. And when we evaluate this limit, we have sine of 0 over 0 is equal to 0 over 0, which does not exist. So what we would do is we would take the derivative of the top and the bottom, so we would get cosine x over 1. So when we evaluate this limit as x approaches 0, we would have 1 over 1, which would equal to 1. So the limit as x approaches 0, it would equal to 1. 1.
What's this? This
An integral.
is a calculator. This is how it works.
So we're given an integral right here. So an integral can help show the area under a curve or the volume of a shape. So when we do an integral, we want to raise all these to the next power. So for example, this x squared would become x cubed, but we would make it 1/3 because when we apply the power rule, because it becomes x squared again. So for this one, it'd be 2x squared plus 2x. So if we were to do the derivatives of all of these, it would equal x cubed plus 4x plus 2. So that matches that.
You want me to fight the function? It's a fight to the death. Derivative!
So a derivative shows the instantaneous rate of a solution. So we have y is equal to 6x squared plus 4x plus 5. We want to find the derivative of this dy dx. So what we can do is we do the power rule right here to make this 12x plus 4. And since 5 is a constant, that gets omitted, it becomes 0. So we ultimately have 12x plus 4 is equal to dy dx, which is our derivative.
Ever wonder what happens when you mix calculus and granola? Miss Smith did. Hear that? That's the sound of Sabaline. Granola, calculus, Miss Granola buds are tasty as hell. Ooh, mama, sheet this off the derivative. Power rule and chain rule, now you're finding the slope. Ooh, velocity, it's a calc class attack.